three-dimensional transportation system and promote smart travel in an all-around way. Make smart transportation reach everywhere. With our digital financial architecture and full-stack cloud strategy, we provide financial institutions with full-stack products, solutions, and services to accelerate the digital transformation of our customers. Get digital finance fully deployed. With our robust digital capabilities, we provide enterprises with comprehensive one-stop infrastructure services. Let enterprises accelerate their digital transformation. Through the end-to-end and full-stack digital innovation strength, we create an integrated digital platform for engineering buildings to fully release the value of data, make buildings smarter. Based on deep insights into industry needs and cutting-edge technologies, we develop mature digital products and solutions to satisfy various application requirements, serving 900 million netizens with innovative services. Make the Internet enter the era of 10 gigabit. The amazing digital achievements result from the strengths that have been accumulated for years. Rooted in China, we have 2 headquarters, 7 R&D bases, over 50 sales and service offices. Serving the entire world, we have 7 overseas branches and apply our products in nearly 100 countries. We take technical innovation as the core engine for growth. We are dedicated to developing technologies with independent intellectual property rights. We actively explore new areas of technology for the future. We fully support the construction of global scientific and technological think tank. We are building an open and mutually beneficial digital ecosystem. We share innovative digital achievements with the world, creating widespread digital success stories. We actively undertake corporate social responsibility, make digitalization more powerful, and make our society warmer. Integration empowers technology. Digital future has infinite value as it is shared by everybody.
HTC is dedicated to providing comprehensive digital solutions that are based on in-depth industry insight. In this way, we hope to help customers from all walks of life to accelerate digital transformations and business innovations, thus boosting the well-being and happiness of people. Together with us, build a digital future for better lives.
H3C, the leader in digital solutions.
Jinan, which borders on Mount Tai in the south and the Yellow River in the north, thrived on its abundance of artesian springs, for which it enjoys global popularity. Mountains, springs, lakes, rivers, and the city itself make an integral whole. The 9 mountains outside the city dot along the Yellow River in various shapes. The 72 famous springs crisscross the landscape. Daming Lake, the #1 spring-fed lake in China, is a jade embedded in the city. The Yellow River, the mother river of the Chinese nation, runs through the city. Viewed from afar, lotus and weeping willows are thriving across the city, imprinting the enchanting landscape on visitors' mind. Jinan, a city with profound culture and history, was also the cradle for Longshan culture, an important source of the Chinese culture that dates back to 4,600 years ago. With a time-honored history over 2,600 years, Jinan has witnessed the passing on and flourishing of its traditional culture over generations. Jinan, a vibrant city, has an area of more than 10,000 square kilometers and almost 10 million permanent residents. The regional GDP exceeding 1 trillion yuan makes it a mega city. The city features good location and transportation. It is the place where China's 5 major economic circles converge, the capital of the only coastal province in the Yellow River Basin, and a hub between Beijing and Shanghai. A sprawling high-speed railway network connects with 254 cities across the country. The 1.5-hour high-speed railway service covers 400 million plus people. Jinan Yaojiang International Airport is an important transportation hub in China and will approach.
I'm just wondering if we're on, or we're just getting very, very close to being on. I fear that I should actually have the stream up, so I actually know what other people are saying. But hi, I presume we're on the top of the half hour. If you've got good hearing, you might be able to hear the clock tower. My screen just changed again. All right. So, hi everyone. I think we're live. We had the vendor presentation, sponsor advertisements, and you've now starting to receive the recording consent message. I'm not too sure if I can see how many people have joined. Some people will be joining via Hoover, some people will be joining directly in the Zoom app, and some will be on YouTube. So I'm not too sure if I should give people a little bit of time, but what I'll do as people are slowly joining, I'll remind everyone to check out the APAN 54 website. There's an exhibition section linked at the top of the page where you can enter some 3D environments for the sponsors of the event. You should also check out either the website, the Hoover-based website, or the Hoover app, where you can find people to collaborate with. There's lots of interesting people from our wide community. You might have heard the clock tower. I'm actually joining you from Lutruwita, Tasmania, on the banks of how would we call it? The Tamar River. The Tamar River is an intersection of three rivers, and it's a meeting place for the Palawa people of Tasmania. It's great to be back at APAN 54. APAN's also a meeting place, but we don't have the joy of actually coming together in the one location at this point, except for our lucky presenters on Tuesday, where we got to see a great array of people coming together to discuss research and education networking. But there's a lot of people from the NREM community, from universities, from vendors, and those just interested and curious on the way that research and education networking has evolved since we last met. And so today, I'm excited. We've got two speakers in this session today. If you were confused by the program and thought that I was speaking, I'm just moderating, right? So I'll be keeping track of questions that the audience might ask, either in the Hoover app or the Q&A section of Zoom. I'll try to keep abreast of both of those to make sure we don't miss anything. So first up, we've got Dr. Naveed Arshad. He's a director of the National Centre in Big Data and Cloud Computing at Lahore University of Management Sciences in Pakistan. So Naveed's talk, you may have got some information about this before. He's hopefully well known in our community. He has a great presentation on the grand challenge of air quality monitoring and how to do that in a cost-effective manner. I won't read out too much of his bio or his presentation. I'll leave that up to Naveed, and I'll join you when his presentation is over in the questions that you have, thought about during his presentation. So Naveed, if you can share your presentation, and the screen is yours.
Sure, thank you. So let me share my presentation and then we will start. So let me know when you can see my presentation in full screen.
Yep, I can see it fine.
All right, great. So thank you very much, Brooke, and thank you very much to APAN management for inviting me to
recording in progress.
This conference, and to talk to you about the work that actually is funded by Asia Connect through the Teen Corporation. So this project we started about 1.5 years ago, and the goal is to develop a system which is cost effective and sustainable to monitor air quality. And I'll talk more about the work, but I would like to acknowledge my co-PI, Dr. Jahangir Ikram, and my collaborator, Dr. Ling from Malaysia. So this is also in partnership with the Higher Education Commission of Pakistan through the Pakistan Education and Research Network. I am from LUMS, which is a university in the city of Lahore, which is the second largest city of Pakistan, but also called the heart of Pakistan because it has so much cultural and historical significance. So Pakistan and this region has been going through a major problem of air quality. And the air quality problem, of course, starts from somewhere in Afghanistan and goes all the way to Bangladesh, passing India and Nepal also in between. And it's a transboundary issue, but so every country is trying to do something about it, because this has just have been accumulating for the past many years. But now the situation is that now we have a fifth season called the smog season that starts in November, when the air is heavy because of the cold season, and all the pollution that's just generating is just you can say trapped underneath it. And because of that, I mean, complicating the more situation, there is this is the crop burning season. So a lot of smoke comes out both sides of the border in India and Pakistan. And then, of course, there are brick kilns that also contribute. So there are multitude of reasons why we are having this air quality issue. And nobody actually knows that what is the deep root cause of it. I mean, when you are in, you can say that season, or even throughout the year, you see all these headlines about the most polluted city and the smog season and the air quality issues. But nobody knows what is going on. Some people say that it is traffic that is contributing most to it. Some say this is industry. Some say it's crop burning. Some say that it is one country, and some say this is other country. So it's just it's a complicated situation. And the atmosphere is not good in those days. I mean, these days we have the monsoons, and the atmosphere is pretty clear. But starting from November all the way until January or sometime to February, the air quality problem is a major challenge and a major impact on the quality and life of the people in this region. Also, this region is quite vulnerable to climate change. So not only the air quality that is I mean, we are facing the trouble. The climate change is also is a problem. But before I talk about climate change, this I mean, some of the most polluted countries also lie in this region. Some in India, some in Pakistan, and this is a major health hazard. I mean, for an already vulnerable population, and there is, of course, life expectancy impacts, and there is a health impact. There are deaths attributed to it, although it's kind of a very slow poison, so you do not see that impact, like God forbid, in case of an earthquake. But this is, since this is a small and slow poison, this is although creating a lot of trouble, but in the long term, especially to more you can say vulnerable people, section of society, like small children or pregnant ladies and elder people, and especially people who work outdoors. So all of them actually face a lot of problem in this season. And let me just tell you that the main reason or the main contribution is the particulate matter, which is the very small particles that actually go into your respiratory system, and then they can be part of the blood circulation also. So that the very tiny particles that create this problem, and you cannot see them from naked eye, but certainly these are the sensors are there to record them. Now, in terms of impact, in 2019, we have seen that an estimate that there are about, from the outdoor air pollution, directly or indirectly, 124,000 people have died. Now, this is a major number. I mean, if you look at just to compare it with the COVID that the world has gone through, the COVID number are not even a fraction of it. I mean, COVID has impacted, but now the impact has subsided. But even in the you can say apex of the COVID pandemic, the number was not that high as we get from air pollution, since because it is not you can say a very newsworthy thing, or something that is not putting a burden on the hospitals, like rows of people coming to hospital. That's why it's not getting that much significance as COVID had. Now, to make any kind of impact, make any kind of you can say intervention for the improving air quality, you first need the air quality monitoring, the data that is coming from it, to see that what are the sources, what are the areas, what are the seasons, what is the constituent. There is source apportionment studies of what sources are creating what kind of air quality challenges. And this is, of course, a challenge, because without this data, we can be just consider ourselves as a blind surgeon on an operating table. I mean, the government can do this or that, but nobody really knows that what is the impact of that, because you do not have the data beforehand and you do not have the data afterwards. The only data monitoring that we have are few stations that are installed by the government, but those are challenges because the number is very low. Plus, they have maintenance issues all the time. So, what people have done in the past few years is that they have, you can say, community-based monitoring has started. So, for example, this IQ Air is and Purple Air. There are two organizations that provide these sensors, and people have voluntarily installed these sensors on private buildings like universities or even on their houses. And there are about 20 or 30 of them. That's the best source of, you can say, air quality monitoring that we are getting at this point, other than the few government grade sensors. Now, our first project that we did in the real-time spatial, and the title was Real-Time Spatio-Temporal Emission Mapping, and that ran from last year, from January to December. And the goal is that to solve the challenge of spatio-temporal monitoring, solve the challenge of air quality monitoring, we should be doing something out of the box. Because, I mean, whatever we do, probably the country cannot have 700 monitoring stations that needs to be installed, because that's the number that experts say that should be needed of a country of size Pakistan and population density. So the goal was to develop a real-time system which not only tell us about the impact, the air quality numbers, but it plans to do it in slightly different way. And I'll tell you that in a second. And then, of course, the main goal was to get the data so that we can help the government to do some kind of interventions. What the idea was to divide the city in form of a grid, where every grid box has some sort of you can say identification that we associate to, and then we install the air quality sensors on top of vehicles. And when the vehicles move, the vehicle will, of course, be in one of the box in the grid, and whatever reading it is giving out, that reading will be stored at a website, and we assume that, okay, for that box we have that kind of air quality or whatever the number of PM and SOx and NOx are. Now, the idea was to install it on multiple vehicles, so when the vehicles move and the readings come out, and they come pretty frequently after every half a minute or so, we just record that, and in the end we have the most of this grid filled out with information that when that vehicle passed, what is the air quality numbers at that time. Now, and again, the goal was to have it on public vehicles like buses, so that because buses run around all the time, and we'll get data across space in this whole city and across time, so whenever the bus operating hours are. So that was the initial idea of developing the system. We developed a whole architecture where there are two kinds of sensors that we plan to install. One were the stationary sensors for, you can say, calibration purposes, and also for getting kind of an ambient air quality data, and then mobile sensors which were installed on vehicles, and the data goes through the Pakistan Educational Research Network and comes to a server at our university, and then it can be accessible to the public and, of course, to the government. So that was the idea. And another challenge that we saw, that in procuring the sensor, and by the way, before I forgot, these are the low-cost sensors. So these are not, you can say, the EPA grade sensors which cost, I mean, a fortune. But these are a low-cost sensor that you can buy in a relatively reasonable amount of money. Another thing was that although some people have tried to use low-cost sensors in Pakistan before, the challenge they faced was that whenever those sensors needed calibration, then they had to send it back to the company where it came from. And then it's of course a whole shipping and taxes and duties and everything, and then the hassle of sending it back. So we saw that mostly for these sensors, the life is just whatever the life or until the first calibration, and then the sensor is just gone. On top of that, there are other maintenance issues. Some sensors may be faulty, some maybe have some over voltage, under voltage. So different kind of challenges that that's which sensor face. So what we tried to do to you can find out a vendor that can actually provide us these low-cost sensors right here in the country. Fortunately, we got hold of a company. It's an IoT company based out of Karachi in Pakistan, and they developed this sensor. And the sensor that you see, it has three things. There's a box that has the sensor installed for measuring different kind of pollutants, and then there is a battery, and then the solar panel. So even if so it has to be charged from the solar panel, but if the solar panel is not available, you have a fixed location, we can get electricity from various sources to power up this thing. Another thing what we did differently was that mostly the sensors from IQ Air and Purple Air monitor only the particulate matter, PM 2.5 and PM 10. Although there are other pollutants in the air, we wanted to find out what is the ozone or sulfur or nitrogen and carbon monoxide in the air, what's the concentration of those gases. So we had those sensors installed also, and then temperature, humidity, as well as the GPS, so that we know that where the vehicle is at that particular location. So we developed the whole air quality monitoring platform. We call it airlens.com, and this supposedly is you can say the one-stop shop for measuring all the data, all the information there. Whatever data is coming, one can see, one can download, publicly available, nothing, no kind of any restriction. And we use the US EPA method for developing the air quality index. And this was, of course, very nice. We had all the, you can say, portal ready, and all the platform was ready to roll out. But then something happened. And I'll tell you what happened. But first, let's see what we did in terms of dividing the regions. So the Lahore city has an area of 700 square kilometers. And administratively, it is divided into 9 zones that are further divided into 274 union councils. Of course, this is a very, you can say, densely populated city. And initially, what we thought that we will just divide it into this grid. But then the idea dropped, because the grid is not a natural, you can say, natural geography of the city. So then we use these union councils and 9 zones to come up with 40 different regions of the city, not based on a square, but based on the you can say the boundaries for the roads, for the population. And there is a link down here. I will share this presentation, and you can go and there is a detailed video of how we came up of developing a whole process of developing regions out of the city. It's based on population density, based on the geography of the region, also based on some data about the already information about, you can say, the air quality. We faced some challenges in the implementation. And the challenges was that, I mean, probably we were naive at the time when we started this project, that ambient air quality and on-road emissions are two different things. Ambient air quality is where you have the air, you can say, away from any kind of source of any kind of pollution. Say you cannot just put it next to an industry or next to a road. It should be somewhere where you can say you'd see the natural air of the city. And the problem on the road emission is that it is about 30% higher. Typically 30% higher, depending on the rush on the road. So if the road is very busy, the number could be 30% higher. But let's say if you go there at night when there is virtually no traffic, there are not much difference from the ambient air quality. Another problem we faced that we started working on, initially we thought that we will put it on buses. But buses have had two problems. But the first problem is that they are all fossil fuel. Unfortunately, we do not have electric buses yet in the city, although the government is planning to procure them, but currently we don't have them. So once you have installed the sensors on the buses, their own emissions from the buses can actually disrupt the value. So the value of even the on-road emission is not really measured because of the emission of the bus. The second problem with the buses was that the buses run whenever there's passenger volume or whenever there is reasonable passenger volume, from 5 a.m. to maybe 12, and then those 5 hours in between, there's no bus that run on that particular route. And then, of course, there are holidays, there are public holidays, religious holidays, when the buses operate on a reduced frequency. And finally, another problem is that whenever we have come across these low-cost sensors, as I talked about earlier, the sustainability of these low-cost sensors has always been a challenge. Because some NGOs, some donor agencies, some industry through this ESR funds can fund those sensors, but long-term calibration, long-term maintenance is already a challenge. So we also thought that this challenge is going to create problems once the project lifetime ends. We were almost ready to install our sensors on whatever we have developed on the public buses, but then we got a surprise from the government, and that was back in November last year. And the surprise was that the government, because they were quite annoyed by the bad publicity of, you can say, the air quality sensors, privately installed air quality sensors. And of course, the blame is going on the government that they are not doing enough. And then basically what they said that you cannot share air quality readings. And if you do it, we are going to put a case on you and possibly put you in jail. And that was, of course, something that we cannot take it lightly. So you can say, just withhold our idea of installing these sensors on the buses. But of course, there are good people in the government. We went to them, we explained to them what we are doing, and eventually, after a few months, we got some permission. In the meanwhile, while the negotiation with the government was going on, what we did was that we at least installed the sensors on stationary locations. So we decided based on our own criteria of where the sensor should be installed. What are the key locations where the sensor should be installed, where it can safe, secure, can provide us a good glimpse of what the values are that are coming from the city. And then we, of course, I'm not going to go into detail of how we divided the regions, but we had a whole algorithm or methodology of dividing the regions for the stationary sensors. So these are some of the pictures from the different sensors we installed. We tried to go towards more private locations because we didn't want to, because we were having trouble with the government already. So we just installed installed just outside the building where I'm sitting, if you see on the left-hand side, and then another one near a parking lot close to where I'm sitting, and then 8 of them around the city, and the locations are all recorded. So with the government came back to us and they said that, okay, you can install your sensors for R&D purposes and you can share the data, but of course you cannot have the government liable for this data because this is your own data, and the government should not be held accountable for the data that you are collecting. The requirement that they posed on us is that you should go through a co-location activity, and the co-location activity is that there is a mobile van which has the EPA grade sensors. So they said that whenever you want to install your sensors, you have to co-locate them with the EPA certified sensors on the van. And once the co-location activity is complete and we are satisfied with the quality of the data, that it's not too much different from what the EPA certified sensors are going, you can say the error margin is less, then will allow you to have this. And meanwhile, other entities like World Bank also joined because they also were installing some sensors. So we did a whole activity earlier this year. And if you see on the left-hand side, all these sensors are on top of this van that you see on the right-hand side. And this is me and my team lead. Huzaifa standing next to the van. So we did this co-location activity for about a week, and then the sensors were ready to be installed. Meanwhile, what happened was that Asia Connect gave us a second round of grant money, and they said that, okay, whatever you think that you have not been able to achieve in the first grant, what challenges you face, you can now fix those challenges and see that how we can install those sensors and solve all the challenges that you have in the first phase. Now, in this one, we did something different. And the something different was that rather than using buses, we have another project going on at our university of electric three-wheelers. So we thought that, okay, buses, by the way, had another problem that since the sensor is very high on the bus, the almost about 8 feet or something, the typical, you can say the placement of the sensor is of human height, which is about 6 feet or something. So with three-wheelers, we actually got to that height of 6 feet and installed our sensor. And since there are electric vehicles, there is no, you can say the value is going to be measured off around in the whatever the atmosphere is, or whether it's on road or ambient. Now, this is one of the vehicle where we started installing our sensors. Now we are in the, you can say, process of procuring this vehicle. We have one vehicle ready that is now undergoing testing of where the sensor should be installed, because we have a battery and we have a solar panel, and then the sensors have to be installed at the right place so that it can get the sufficient air to monitor air quality. Then we did another thing, and that's very interesting. We said that rather than having random routes of buses, now these three-wheelers are kind of at our control, at least for the duration of the project, and then we can develop a sustainable modeler of our own. What we did was that on the left side, you see the bus routes that we were planning. So buses come around and then they follow a certain route, and then they go from one part of the city to the other, and then they come back, and they just follow all that route. All that route is typically on major highways or major roads, which are typically have more passenger traffic and more vehicles. As a result, it has a lot of on-road emissions. So we thought that rather than using the buses, why don't we provide the last mile connectivity through these vehicles, through these three-wheelers? So if you see, this is the same map from the same vicinity. On the left-hand side are the two bus routes that may crisscross each other. On the right-hand side is the last mile connectivity from different bus stops. So the bus stop, passenger got off from buses, and then they go into our three-wheeler, and the three-wheeler follow a certain fixed route. But there are two advantages to that fixed route. One is that it is going through neighborhoods that typically have less on-road emissions because of less traffic density. In fact, some of them have so low density that you can be very, very close to ambient air quality. And then we donated these stops, which are the purple, you can say, dots on the right-hand side, where the vehicle stops for a few seconds, and the sensors automatically, since they are reading this for every 15 seconds or something, and then they get the reading for a stationary location. So with a three-wheeler, what we were able to do is that we are getting the values of the neighborhood from roads which have less traffic, as well as we are stopping at certain location and kind of using our vehicle as a stationary sensor. And then, of course, these vehicles do a run at least one time in an hour throughout the 24 hours, even if the buses are operating or not. Since they are in our control, we can have them go around. So this provided, so these having these vehicles under our control actually gave us a lot more, you can say, control over the project, as well as a lot more control over how do we measure the ambient air quality. Another thing we did in our platform is that we tried to mate our platform, and this is an effort that is even going on as we speak, is to have different sources of data from the city, from the private providers, from the government, from some of the consulates and embassies that have installed their sensors on a voluntary basis, and try to collect all the data and present it as a one-stop shop for all the emission data available for the city. And that then somebody can say that, okay, filter out the data from this source or that source, or I want to see the data from EPA certified sensor only, or I want to see the data for this region, whatever number of sensors are available. So you can have a lot of data sources that are available. We have developed open APIs. So anybody would like to share their data with us, the API is available, and we just need to get the data and put it on our website. Finally, I think this is my favorite part of the project, is how do we make it sustainable? So the project funding is at most 1 year, maybe a few months more. Maybe we get another grant from somebody else or from the same funding agency. We don't know. But the problem is that as soon as this project finishes, typically most of the sensors, most of the vehicle just becomes redundant. Nobody really cares about that. So we wanted to develop a model where it has a sustainability model packed to the sensor, because sensors are not there for business. Unfortunately, this is not a startup where you can get money from other people, sell your products, sell your services, and then get money. Nobody's interested in air quality numbers, at least for now, for generating a business. So we thought that, okay, what can we do? These three-wheelers, if I just go back, these are passenger vehicles, and we have 2 or 3 different models of them. There is one which is a 3-passenger one there's a 6-passenger one. Now, these are, as I told you earlier, that this is providing the last mile connectivity. So this is generating a business. So when this is generating a business, and so these are three-wheelers, electric three-wheelers, their running cost is almost 1/3 or less of a typical fuel-based equivalent. What this gives us is that we have the 2/3 money or more that can pay for the salary of the driver of the vehicle. And a part of that can be spared for the maintenance of the whole platform, for the sensors, for any kind of, you can say, maintenance that we do, any kind of calibration, because we need to do calibration of these sensors every year. And that calibration money needs to come from somewhere. So what we did with this, or we are trying to do, so our first vehicle is out and other vehicles will be on road by end of September, that about 25% of whatever they are going to earn will be used for the maintenance and the upkeep of the sensors and the sensing devices, whether it's battery, because the battery has a degradation issue. You have to replace the battery after every few months, and then calibration of the sensors. These are the 2 major expenses that we are going to incur. And this 25% of the amount is enough, according to our calculation, to make sure that the platform is running, the platform is operating even after the duration of the project finishes. We hope to have this as a model for other cities as well. Of course, now we have to collect the data, talk with the climate air quality experts, and see that whether data is usable. Fortunately, other entities like World Bank have partnered with us. There are other agencies that are also in negotiation with us. So I think this project is gaining traction, and the kind of, you can say, the approach that we are that we are employing here is also getting traction. So hopefully we are working on this, and I think at APAN 55 we should be able to give you some real solid numbers of what we have learned. And so until then, I think thank you very much for listening, and I'll be open to comments, questions, feedback. I'll be happy to listen to the feedback from colleagues around.
Wow, that was really interesting, Naveed. And yes, it's different than your previous talk. It's an improvement. And I still have some questions. So I haven't seen any Q&A questions turn up just yet, but I'll ask my questions now to give the audience some time for them to, to think, to digest the information. And so I think I had this problem before. The last mile connectivity is actually it's not a connectivity, it's actually making the final journey, isn't it, from the bus stop to the person's home. So that confused me a little bit. But talking about connectivity, how did you actually get the data out of these sensors? Do they talk Wi-Fi when they're near a hotspot, or do they have a cellular uplink?
Right. So initially, we thought of putting up our own devices for getting the data from the sensor, but we realized that there is actually a regulation in Pakistan that you can only get data from a certified mobile service provider while you are away. And the Wi-Fi is tricky because there are not public hotspots available. So at best, when you go around and come back, you can actually download the data. What I think our vendor has done for us is that they have actually installed a SIM from a local vendor. So the system already has a 4G connectivity. And since the 4G network also may create problems, or the vehicle is out of the network, you can say, area of coverage, there is a local storage of data. So whenever there's connectivity, the data will be available back to us. And so at this time, we are using a SIM inside the box, which is connected through 4G, that is sending the data to our network.
And so I've got a question that's come in from Mohammed Tarit from BDREN. So I'll modify his question ever so slightly. He's asking, since these hotspots or the air quality monitors are moving, he wanted to know if there's much variation from the data collected from different sources. But what I'm going to say is, do different three-wheelers have different values when they get back to the same spot as others?
That is a very well a possibility, because maybe on one side of the road, a vehicle maybe is having less of smoke, I would say, and on the side there's more smoke. Those data will start coming up when the project will have we have about 12 vehicles that we will put up on road by end of September. I think those are the numbers that we are expecting to be different, but we need to have a way to how to maybe average it out, or how to maybe make a meaningful number out of those values. We have some air quality experts with us now, since the World Bank has partnered with us. So they have a really good experts on their team. And together, I think we'll try to find a method where those numbers, we can minimize the variance between different numbers. Also, we also want to, maybe because of the privacy issues, we do not want to put the location of the vehicle right there where the location is. So it will be an area where you can find out, okay, what the value is. Whether we average it out, or we take the lowest one or the highest one, or maybe some other algorithm, that will really depend on what kind of values we are going to get once we install these vehicles on road. Another important point is that we would like to get some data before the smog season, which is in October. And when the smog season kicks in, let's say in November, we would like to get another set of data. Then we can compare both of them and see that what kind of variance we have under different circumstances, or under different air quality, you can say, seasons, I would say. Yeah.
You also mentioned early on that you originally needed some 700 monitors to cover the area, and then you've got a certain number on these mobile, three-wheelers. So have you done a calculation of how many sort of effective or virtual monitoring points you've got, because they actually do move around? So how many, you said you wanted 700 and couldn't afford that. How many do you actually have now, and how many are they effectively, because they get to move?
That's a very interesting question. And I think we grappled with this question of how much air quality monitoring station do we need in a particular city. So initially, we thought that maybe US EPA method of determining how many air quality monitoring stations it required is a good method. And somebody said that, okay, no, you should go for the Indian method or the European method. But then when we talked to the air quality expert, they said that every country has a different situation in terms of air quality. You cannot take the EPA method and apply directly to Pakistan. With this project, I think what also we are going to get is some kind of information of what's the variance in the air quality monitoring amongst different parts of the city. And that will determine that how many monitoring, ideal number of monitoring stations are we going to get. Since this is a small project, or you can say just a pilot, we'll have 12 vehicles, maybe 8 of them or 9 of them will be on road at a given time. we have just selected an area of the city that's, I would say, about 20-25 square kilometer, and there we will be running our vehicles. So this is you can say this is a more affluent neighborhood, and this is not covering. This is kind of a private area, and this probably will give us more control and also an idea of if we want to expand to the whole city, whether we need 700 virtual points or we need even more or less. That probably number will come once we start getting the data and find out about the variance.
And you made a call for accepting data feeds from other people. Are they other data feeds in Lahore? Are they other data feeds in Pakistan, or are they extended
Right.
to the region?
Starting with Lahore, and then of course when the platform will expand, because once it is good for Lahore, it is good for any other city. I would even suggest all the people in the APAN network that once this project finishes, I mean, our project is going to be open source. We are not going to be having any kind of IP rights over it. If you want to take it to anywhere, just take it and replicate it. We'll try to help as much as we can.
Yeah, my home state of Tasmania has a statewide LoRaWAN network that's was built by a commercial entity, funded by the state government, and people can do sort of individual infill services. So it's both used for R&E purposes as well as commercial purposes. And so they've developed a sustainability model for making that so that the different telemetry sensors can work in that regard. And I know that in the Netherlands, SurfNet has built an academic LoRaWAN network, while the phone company KPN has their commercial LoRaWAN network separate for different purposes. So are you working with anyone to move away from those SIM cards to LoRaWAN as a technology for update?
As we speak, not exactly, because our focus is on having the platform up and running, getting the real data. I think following that, we'll be looking at what are the other sustainable options of maybe getting the data. We need to partner with some, you can say some service provider. That I think we'll do once we have the platform up and running. I think there will be many service providers who would like to help us out. We have not talked to them yet. And again, another thing is that there are some pretty strict regulations from the Pakistan Telecommunication Authority about how to use these different bands. So I think those we need to be careful of. So yeah, I think this will be a logical next step once we have the data coming.
And it's interesting. Apparently, in my home state, it's a government requirement to do a state of the environment report. I think it's supposed to come out every 5 years, but it hasn't come out for the past 13 years. So sometimes, even in places that espouse being green, we produce 100% of our electricity through hydroelectricity, but still our government doesn't want to release an environmental report that may shed some negative light into some areas of our forestry or fishery practices. So it's interesting. I think, just in concluding, I think that NRENs provide a public good. People, there's certain things that NRENs have to do for the security or the quality of their network that they can't directly monetize. And I think that your project is incredibly innovative, not in collecting air quality data, but actually trying to find a business model that will work with electric three-wheelers. And I hope that maybe the government can do something on the road tax or registration requirements to further lower that for vehicles that have these sensors fitted, so that you don't just have so there's an incentive for these drivers of these three-wheelers to want to have air quality sensors.
So I think on that front, I think government has done some remarkable steps. They have actually reduced the registration cost of any kind of electric vehicle to, just 5% of the normal amount. So that's virtually free. And then the road tax is also 75% less. So I think that's a good, you can say, incentive for the people to own the electric vehicles. So I think that's already there. We just need to now have some sensors and make a sustainable model out of it.
Well, Dr. Naveed Arshad, I'm really sorry that you cannot hear an applause from the audience, right? It was a great talk, and I'm sure there's a lot of interest from the wider community. Everyone can try and find you on Hoover, or get in touch with APAN Secretariat or myself, and we can put you in touch. But we will be looking forward to, I think you said you were going to provide an update at APAN 55 in Nepal.
Certainly. I'd love to provide an update, because with more visuals and the more data, and I'll be, my team will be happy to collaborate with other colleagues in the region and anywhere on these kind of projects, and we'll be very open to collaboration. My contact details are here. You can contact me through any medium you prefer.
That's great. There's also an Internet of Things working group within APAN. I'm not too sure if they're, I was unable to attend their session, so I don't know if they're dealing with just the technology or the practical applications of using sensors. But yeah, hopefully we'll see an update within that fora or on the big stage when we finally get to meet in Nepal. So thank you very much for your time.
Thank you very much.
Our next speaker, Dr. Tomohiko Moriyama, his talk on telemedicine before, during, and beyond the pandemic. I think, everyone here has survived the pandemic, right? But that's not the case for all members of the APAN community or the extended family. They haven't necessarily been as fortunate. And so Dr. Moriyama, he's an expert in gastrointestinal endoscopy as part of TEMDEC. So hopefully people know TEMDEC from the telemedicine group. For 20 years, he's been a diagnostician for the treatment of gastrointestinal cancer, and has taught gastroenterology and endoscopy techniques to 100 Japanese medical residents and 200 foreign trainees. And so, Dr. Moriyama, the screen is yours. I look forward to the presentation.
Okay, thank you for introduction, Brooke. And I really appreciate all the APAN Secretariat and Brooke to give me such kind of big opportunity to talk about our activity on telemedicine. So, okay. All right. Hello, everyone. This is Dr. Tomohiko Moriyama from Kyushu University Hospital. Myself is, as I mentioned, from Brooke, GI endoscopist, and also a chair of APAN Medical Working Group. So today, I'd like to talk about telemedicine activities of TEMDEC, and also I'd like to talk about a bit about what happened in the telemedicine field, mainly in doctor-to-doctor education. Okay, now we have been suffering for the pandemic for more than 2 years, but in general, the measures against NCD is a big issue in the world. As you see in this figure, disability adjusted life years of NCD is increasing year by year. And this non-communicable disease, NCD, kills about 41 million people each year, which is equivalent to 31% of all deaths. So it is very important how to tackle with non-communicable diseases, NCD. But the measure against NCD is quite diverse in the world. This is a heat map of NCD-related mortality under the age of 70. As you see, in the developed countries, the mortality in these premature ages is very low. But in the developing country, this mortality ratio is quite high. So it's a very big issue. and there should be medical disparities in this area. Actually, the leading cause of NCD-related death is CVD, cerebral vascular disease, and cardiovascular diseases, followed by cancer, respiratory diseases, and diabetes. So, to save the patient from those diseases, prevention and early diagnosis is very important. About CVD diseases, prevention is quite important because sometimes there is subsequent complications such as paralysis or exercise limitation in CVD diseases. So prevention is quite important. So it is very important to control the diabetes, hypertension, dyslipidemia. These are the major causes of arteriosclerosis, which leads to CVD. And also prevention from avoid from smoking is also very important. But in the cancer, this is a kind of age-related diseases, so it's very difficult to prevent. So early diagnosis is very important using blood analysis and image diagnosis such as endoscopy, CT, ultrasonography, and things like that. This figure shows the age-adjusted cancer incidence and mortality. As you know, Japan is one of the aging society, super aging society. That's why the incidence of cancer is higher than that of the world. But comparing, I'd like to show, but the situation is a bit different from other countries. I'd like to show one example, gastric cancer. The incidence is quite high in Japan, but its mortality is less than 1/3 of its incidence. Comparing to its incidence, mortality is very low. But in other countries, incidence and mortality is almost same, which means once the gastric cancer is diagnosed, most of them died of gastric cancer. Actually, in those countries, the gastric cancer is detected in advanced stage. So surgical operation is needed. Of course, they should admit, and also there is some risk of recurrence and also death. But in our country, most of gastric cancer is diagnosed at a very early stage and will be resected endoscopically. Of course, the patient recover very soon and they can go back to work just after the discharge from hospital. So early diagnosis is very, very important to save their lives and also save their quality of life. So, of course, there are so many key factors to get this kind of very, very good results in this field. Such as cheap health checkup system, free access to healthcare providers, and something like that. But most important thing is education. Actually, there are so many medical associations in Japan, and they established a very well-organized education system. So, and through this education system, we can share our knowledge and experience among doctors. So we can achieve early diagnosis and minimal invasive therapy. That's why many foreign doctors visit us to learn what we do, and also we share our knowledge and experiences through on-site training. And we sometimes go abroad to do some medical procedure and also do some live demo or something like that. This, as you know, of course, this kind of on-site training is quite effective, but it's very short-term and also intermittent usually. And we should pay travel expenses and also accommodation fee is needed. And the only limited number of doctors can share the knowledge. through on-site training. That's why we started telemedicine activities connecting many institutions like that. But for medical education, high-quality images are essential. In these 6 photos in the stomach, there is a gastric cancer. Can you detect it? These are the early gastric cancer, and almost of them, all of this lesion were resected endoscopically. If we can't detect such kind of subtle changes in the stomach, we can't save the patient life. So to educate the doctors, it is very important to use this kind of high quality of images. So we decided to use this advanced research and education network. We have a good association, APAN. So under this APAN, as a former chair of the medical working group, Dr. Shimizu developed this group in 2005. So using this broad and stable network, we can connect many countries using our own PC, using free apps and video camera like this. It's quite cheap and user-friendly devices. We have organized various kinds of telemedicine. One most major one is a webinar. I suppose that most of them are quite familiar with this webinar. And in medical field, case discussion is also very important to share the experience of interesting or rare cases. And especially in the surgery and endoscopy, learning the technique from experts through live demo is very important, and also many doctors enjoy this demonstration. This is a conventional lab demonstration. Many international faculty go abroad to show their amazing technique, and once they will get together at the hospital very close to the main venue, and their technique will be broadcasted to the participants like this. But for these doctors, they should do their medical procedure in totally different atmosphere. Of course, endoscopic room and operation theater is different, and they should use a different equipment, and the team member is not so familiar with them. And sometimes the indication for the treatment is totally different from ours, and they cannot take care of the patient after they go back to their own country. And sometimes we feel some language barriers and jet lag is a big issue for the demonstrator. And for the organizers, they should prepare lots of patients. It's sometimes very trouble. So we connect Asian institutes using the REN, Research and Education Network. This lab endoscopy was performed at APAN 24. At that time, endoscopic procedure was shown from Kyoto, Japan, and Fukuoka, and broadcasted to the China, Korea, Taiwan, Thailand, Malaysia, and Germany. To do such kind of big event, there should be through this kind of big event, we have accelerated telemedicine activities. And these are the keys for the success of telemedicine. One is needs from doctors. Without any needs, no telemedicine. Second is the internet as access. We can use a research and education network for the live demo and also for other kind of webinar, the case discussion. And other important thing is skills by engineers. So co-working with engineers and medical staff is essential to make telemedicine successful. So we have trained many engineers using APAN network. This is a medical working programs in this APAN 54 meeting. Like this, we organize 12 meeting in this APAN. So, and like that, we have organized many programs under the APAN Medical Working Group. And we have invited many foreign engineers, and also they joined to the APAN. And through this on-the-job training at APAN, they can do a hands-on training at many medical sessions like this. This is Singapore in 2018, New Zealand in 2018, and Korea in 2019, like this. And also we have invited many engineers to our center, Kyushu University Hospital, and lectures was given to them, and also hands-on training was performed like this. And our engineer taught them how to connect the medical devices to the internet at the operation room and endoscopy room. We have fostered leaders in engineering field in each country. And also we have organized domestic workshops like this. Actually, there is a very limited opportunity to meet the doctor and the engineers. So we have organized a domestic workshop to have the and doctors and engineers get together and discuss how to accelerate telemedicine in their own countries. We have conducted this workshop in Indonesia, Philippines, Vietnam, Nepal, Myanmar, Kyrgyzstan, Bhutan, Mexico, and Chile. So through this kind of repetitive workshops and education, accumulated numbers of telemedicine programs is steadily increasing. And now the special number of the special interest group is expanded to 40. And these are the contents of our telemedicine program. Like this, we have various kinds of programs. The leading one is endoscopy, followed by surgery, pediatrics, oncology, technology, healthcare, or something, and something like that. As you know, the COVID-19 pandemic has started in early 2020. This is a quite new disease, and no one knows what happened and in Southeastern Asian countries, and no one knows what the virus act and how to prevent people from the infection. At that time, we remember the past experience at APAN 23. At that time, bird flu was a very serious issue, especially in Asian countries. About these diseases, Indonesia has a lot of experience. So we organized this conference and share their knowledge and experiences among participants. So based on this experience, we conducted international teleconference on COVID-19 at early 2020, just the beginning of the pandemic. connecting Asian countries and Central Asian countries like this. We have organized this conference 3 times, and actually more than 4,000 attendees enjoyed and our discussion, and through our the presentation, they, I suppose, they know and learn how to prevent their staff from COVID, and also how to prevent the people from these diseases. And through this pandemic, teleconference systems are dramatically improved. Previously, we used a little bit complicated system and a bit expensive system. But through the, of course, we have this kind of easier, cheaper, and convenient system for teleconferences, but its quality is not so good at that time. But through the pandemic, the quality of these teleconference system is dramatically improved. And due to the moving restrictions, and to share the knowledge, and for medical education for doctors and students, many countries started telemedicine. In 2020, we organized a teleconference with Bhutan, Myanmar, and Central Asia and Caucasian countries like that. And even in Japan, we can see a dramatically increasing of web meetings. In our hospital, many departments started telemedicine like this: internal medicine, surgery, pediatric, ophthalmology, biochemistry, or some, and things like that. It's a kind of general expansion using a very convenient system. And we have supported many virtual meetings of medical associations in Japan. In 2020, June, this is our first time support for the Medical Association of Japan, and successfully we success to support this teleconference, and attendees were dramatically increased comparing to the last year's Congress. And after that, we have supported many congresses like that. And the participation styles was changed like this. Before the pandemic, many institutes joined our teleconference by groups like this. But after the pandemic, the attendees joined personally using their own PC, smartphone, or tablet. So, of course, we should control the many attendees, but it's not so difficult. And now they are quite familiar with this kind of teleconferencing system. So the less technical support is needed. And the setting of live endoscopy become very easier. Before the pandemic, we should prepare many engineers and complicated system like this. But by the dramatically improvement of the teleconferencing system, now we can broadcast endoscopy using one PC with one doctor or engineer who are familiar with ICT systems. The lower right lower photo shows the endoscopy live demo from Japan to Russia and Europe. Through this improvement, we can provide a technical support remotely. Now, the telemedicine is for everybody. More than 20 years ago, we can only connect the big hospital using the big internet like REM. But now the commercial network is improved, and we can connect these small hospitals and also medical personnel. And also using the user-friendly teleconference system. Of course, through these changes, the attendees, the number of attendees is dramatically increased like this. So to do a teleconference, international teleconference frequently, we should do lots of coordination tasks like this, fixing the date and times and the registration, announcement, making flyer, or let them know their link address or something like that. It's very complicated. So now the support of coordinator is very important. The co-working with engineers, coordinators, and medical staff is now the key for good telemedicine. Of course, through this pandemic, many doctors are aware of the usefulness of telemedicine. This is a live endoscopy from novice to experts. The experts in US makes many advices while watching the procedure from Nigeria. And this kind of trial is already started in Japan. This is one example, connecting Kyushu University Hospital and Sapporo, the very northern part of the Japan islands. And so using the internet, the expert in Sapporo using annotation like this. And other trial is already started in various countries. This is a report from, I'm not sure where, forget where the country is, but anyway, this is a telerobotic ultrasound. This ultrasound device is controlled remotely, and show the images was shown on his PC like this. We can see the gallbladder stone like this, and also we can see the small infant in the dream like this. So we can make a diagnosis using these devices. And now in China, robot-assisted laparoscopic telesurgery has just started. Connecting this surgeon and the remote area, he do a remote surgery using this robotic system. This is it's really amazing, but it's real. So this kind of advanced medication is now just started. And also education is changing using the metaverse and extended reality like this. At the APAN 47, the people demonstrated this kind of metaverse system to learn the anatomy. And also at the ATS 2019, this guy is very famous for XR in medical field, showed a presentation about pre-operative plan using the XR. And also metaverse is a kind of a very challenging for the medical education. The young doctor can train their own skill without harming patient and the animals on the metaverse platform. So it is very quite, I suppose it's a very good field to do this kind of training. And also many international online consultation is now doing this is a consultation from patient, like second opinion, and also we have many consultation from foreign doctors. We use the patient private information to do this kind of online consultation. So the stable and secure network are very important and essential to protect their privacy. So in this kind of advanced telemedicine, we need a support from skillful engineers, and also stable and broadband network is essential. Ladies and gentlemen, this is a summary of my presentation. Telemedicine is becoming more popular and casual in the COVID-19 era. And as I mentioned, coordination skills are very important to make telemedicine more casual. And also, advanced engineer skills and stable broadband network are essential for the future telemedicine. Finally, I'd like to say thank you for your great and persistent support for our telemedicine activities. Thank you for your attention.
Thank you very much, Dr. Moriyama. We do, in fact, have some questions from the audience, and so I'll make, cancer scares everyone, and at least by the time you've reached my age, you've had family, friends, or colleagues that have been touched by it or even taken by it. And so, a question from Patch Lee. You had a picture that had 6 pictures determining cancer in one of your slides. Has there been much growth in the use of AI to be able to, better help identify that and assist experts that have to look at, I think looking at slides, I think there was a big scandal in Ireland, where Ireland had outsourced the checking of pap smears that went to an organization in the US that did a very poor job of assessing them, and they didn't have, other AI techniques to assist people in having to look at lots of slides. So, has that changed, and is that work that appears within the within TEMDEC?
Okay, actually, the TEMDEC is just an educational sector, so we are not trying to develop such kind of equipment or devices so far. But I myself is an endoscopist, so I have a bit of knowledge about on this field. As you may know, that AI is now installing to the medical field, especially in the image diagnosis. The endoscopy is a good field for AI, actually. In CT and the MRI and also ultrasound, we can review the images after the exam. But in endoscopy, we should make a diagnosis during the procedure. It's a totally different. So that's why AI is quite useful and already launched in colonoscopy already, and will be launched this year in about gastric cancer. I'm not sure how they can definitely detect early cancer or not. But anyway, already some papers, articles mentioned that its sensitivity is quite high. Of course, almost the same with the GI expert. So that's why I think the AI should be very quite useful. But same as AI driving, someone should be responsible for the results. So only the doctor can do it. That's why I think that this kind of education is quite important.
Okay, and so a question that Mohammed Taurita had from BD-REN, a lot of the telemedicine tools that you're talking about now just use the commodity internet. You've gone from specific video conferencing services, provided by WIDE, to now general purpose tools like Zoom. So how does the R&E networks still differentiate in the areas of telemedicine, and how are they changing to remain relevant?
Okay, thank you for this question. Actually, before the pandemic, only RAN is a good infrastructure to do a telemedicine. Because then at that time, the commercial network is so narrow and the quality is not so good, actually. And also the teleconference system needs a very broadband. So that's why it is sometimes very difficult to make some teleconference before the pandemic. But as I mentioned, the system is dramatically improved, and also the commercial network is also improved. That's why we can do this kind of a conference and discussion using Zoom or WebEx or something like that, Teams or something like that. We can do it now. But for advanced telemedicine, such as live demo or other future telemedicine, as I introduced, I suppose that we need a broad and stable network. That should be a RAN, I think.
And I have some questions of my own. So I wasn't aware that engineers also attended some of your events. And so, historically, H323 video conferencing, which actually isn't very secure, and then very evident at the early start of the pandemic was this phenomenon of Zoom bombing, where people would turn up and play disruptive music or disruptive videos in Zoom events, which caused Zoom to look at security. What is the sort of next biggest technology change that needs to happen that the IT engineers and the research networks can help in improving telemedicine?
Okay, thank you. It's very also important question. As I mentioned, telemedicine have a very good future because the network is improving. Now moving to 5G and 6G, 7G, I'm not sure. But anyway, the internet is more stable and becoming more broad or something like that. So that we can do some kind of a medical procedure or remote patient care on the XR or metaverse or something like that. Regarding metaverse, we are not satisfied actually. We can do nothing about medical procedure on the metaverse so far, I think. But I'm not sure what happened in the next 5 years. So at that time, of course, we would like to work with engineers, and also we should also share the knowledge and also new technology about this field. So also the support from the skilled and engineer is essential for us.
Yeah, I've had the pleasure of going to see some of Gunther von Hagen's exhibitions, and this is the anatomist that developed plastination that dissolves the human body, and you have a version of the vascular system, for instance, or very good representations of muscles. So that's like a pre-metaverse version of that. And he did a TV series called All New Anatomy. All New Autopsy Live, right? Where he did live autopsies in the UK because body donation was so low. Historically, body donation became an industry, and famously, William Burke and William Hare they were making money delivering dead, cadavers to Uni of Edinburgh, and then they started to actually actively kill people so that they would have bodies. And so, students don't actually have much access. So, as a patient rather than a doctor, I'd like to know that the medical students get to work on a cadaver at some point before, having to deal with me. But how can the improvement of understanding medical procedures and practicing medical procedures in the metaverse improve, patient outcomes?
Okay, thank you. Right, Okay, before all right, okay. Now we are in this pandemic situation, so the access to the operation theater for medical students is sometimes limited to prevent, to save the patient from infection. So, but if we have some kind of 3D system or metaverse system to show the operation technique or other, and also if we can do some medical education on that platform, we can educate them without the risk of infection. And also, sometimes it's very difficult to close to the surgical field for the medical students. Don't be so close. Yeah, sometimes the surgeon says so. When I was a student, I was said to that. But anyway, if there is some camera inside the body or something like that, and they can watch what is performed in the body or inside of the body or something like that, that should be quite an effective education for students and also for doctors, novice doctors. So this kind of such kind of this metaverse or XR, and also XR is quite important to do some plan, to make some plan before the surgery or something. So that should be very challenging, and also I think it's kind of promising.
Yeah, I just watched an old TV series that I liked once. It was filmed in the 1980s, and it was filmed on videotape and not on film. And so these days, it looks incredibly awful on my big screen TV. And I just noticed that, this Zoom session, it says that I'm receiving the video as 320 by 180 pixels. That's not good enough for doctors or experts to assess medical images. So I think that really high bandwidth networks are still going to be needed, and uncompressed video. You've got this strange compression artifacts around me. You don't want compression artifacts that might mask a real a problem, the sign, the early sign of cancer, or hide colors in that might be prevalent in high resolution scanning. So I still think that RNE networks will still be needed for the bandwidth that we provide, because I don't think Zoom is great for learning about your experiences, but maybe not great for all instances of telemedicine. I thank you for your time today, and I thank the audience for being patient with me and staying for the entire broadcast. You can continue to collaborate with everyone by the Hoover platform and ask questions there. People from TEMDEC, as well as various chat groups within Hoover exist, so you can reach out to people. Also the exhibition space, thanking the sponsors that have helped make this event possible, as well as the members of the program committee that have put together an excellent program that I hope you're all enjoying. You've got a little bit of a break now before the next session start, I think we're now done for this this session. I thank you all for your time, and I'm sorry you can't hear the audience applaud, but we do appreciate everyone who's spoken today.
Thank you.
Thank you all.